now. Good. Yeah, ECI. Okay, so you see this little right up, you see MXDBC and you see ECI. Okay, well, what does it mean? This little checkbox, check circle, radio button, it has this view mode. So if I have it set to ECI, then the view mode applies to ECI, and if I have it set to MXDBC, then the view mode applies to MXDBC. Okay, so in this case, for example, you don't see show single image, but because MXDBC has 6 cameras, it has this view single image option here. But so ECI means that now it only applies to ECI. So if I would go to login, I will see in system control that when this is checked, then this area applies to ECI and this area applies to everything. So it means that it says up here, settings and operations for ECI inspection application. Yeah, and if I would put MXDBC, then it says settings and operations for MXDBC inspections applications. Okay, so that's this little area. Oh, sorry, this little area is then only for MXDBC in this case, and when I put it to ECI, then this little area is only for ECI. Okay, so it says here generate reject signal by system, so that is valid for all applications. If I turn that off, then it will turn off the reject. So you will not reject anything, not on ECI and not on MXDBC. If this one is turned on and this one is turned off, generate reject signal for application, so that is for the ECI application. So the rejector is turned on, so on, but it will not reject on ECI. Huh? It will not reject on ECI, but if I go to MXDBC, it will be rejecting on MXDBC. See? So just little detail. So let's turn it on. As you can see here, you also see that it says save rejected images and save accepted images. Okay. If I hit save accepted images, it will save all accepted images with an interval of 1. So that means it will save all images. If you have everything accepted and rejected, it will save all images. But that's way too much, because every image is like 2 meg and there's like 4 scans per second, so that will be that is too much information to save. So the system will then stuck or clog. Yeah. But you can say save every 100 good images and every rejected images. Normally we leave this on and we leave this off. But sometimes you just want to have an image saved, a good image saved, or every 1,000 or so that you have a reference to what a good image looks like and what a bad image looks like. In this case it says save rejected images. I would strongly recommend to have that always on. Yeah. Good. Save next image as sample image. When we go to ECI analysis, and sometimes we have, for example, in flange, you have this flange ROI, you have this image here. And this image is a sample image. So if it's not representative for the can that you are using, then you want a new sample image. So that means that you have to click on this one, save next image as sample image, then you hit OK, and then the next image that will pass through ECI will be the image that just passed, that will be the sample image. And so the next image that it takes will be the sample image, and that will then appear, for example, oh sorry, not here, that will then appear in the flange area here, or that's the same image that will appear in the sidewall image here. Okay, so that's the same image. A background image to be able to align your regions of interest, the ROIs. Very good. So now we're going to continue. So you see this red. So if this one was turned on here, generate reject signal, it'll turn green. You see, so this one is that button, and this one is the button for the MXDBC, and this one, this button, is exactly this one, right? It's just a checkbox, an extension of the checkbox. Okay. So now let's continue to see what the ECI does. Maybe we need at least one can to be able to see something. So let me turn on this save accepted images also. So pass one can, so that, oh, start, of course. Without starting it won't work. So let's get one can past the ECI. Don't know what went wrong, but what happened? Yeah, but it stopped. So is it coming? Good, thank you. See, now it also saved this image here because I had told it to save all images, ejected, rejected and the accepted images. So I turned that off because if you leave that on and you start producing, then the machine becomes very unresponsive because it tries to save all images and do all the analysis also. Okay, so what do we do here? What do we see here? First, log in as let's say 123 as an operator. What can we do as an operator? Of course, that is it's possible to it is possible to adjust that where what we show here again. Settings. Oh, I have to stop, of course. Stop. Settings, and then in application settings To say that again, in access control you can change who can do what with certain things. So in start stop for the operator, and or maybe only for the administrator, etc. And so the operator in this case, log out, log in with 1, 2, 3. We log in as the operator here. Operator down right here, you can see it, remember? And now you can say start stop, but you cannot touch any settings. The operator is not able to touch a setting, which is normally what you want. If the machine is set up correctly, then you don't want operators to decide what can be turned on or off, or if not, they need another password. Let's say the supervisor password, 1, 2, 3, 4 in this case, or the expert operator password. This is the expert operator password, and then they can change a couple of settings. And one of the settings we show here is the intensity threshold for the can finding. See, so the can first of all must be found. The can is in the image and it must be found. So if you see here this green line here, so if I go to view mode and I don't want to see the analysis images now, show image, you see that the can is found with this green line. It finds that because of a threshold. You see, this is the can search or the can find area. It finds this, it thresholds this image, and then it finds this green line depending on the threshold image. So if that's not set correctly, so let me put it to 10, that's not correct, I suppose. And we say show image. You see, this image is not only seeing the can, it's seeing all these kind of things. It sees the track, it sees the side rails, so we don't want that. For that reason, you need to adjust the can intensity threshold to another number. Let's put it to 100. Hey, you see the green line is not nice here. So show image 100, it still works, but you see that there's already too much black maybe in here, so it may make a mistake, but 100 will probably work. If I put it too high, 150 for example, that's probably too high. No, it's still working. Put it to 200 and 200, yeah. Just so you see that it doesn't work, yeah. It still works. Okay. It's very stable in this case. Okay, that's good. So 100, so 70 was the number, because then I have it nice and white, and I know that it's going to find the can border edge very correct. Good. That's the can finding. So if it can find the can, then it's okay. Then we have, don't forget about this, because you really want to find the can. That gives very much better result. Roundness. Okay, the roundness of the can. Well, I don't know if this can is round or not, but it says 0.99 as can access ratio, you see? What it does, it takes the longest edge and the shortest edge, and then it divides the shortest edge by the longest edge, and you get this number. So if the longest edge and the shortest edge is the same, you divide x by x, so you get 1. Okay? So if it's not the same, then you get x minus delta divided by x, which means you get not something that is very close to 1 but not 1. So in this case, in roundness, you see that it should be 1, but it can deviate 0.04. So it allows 0.96, but it really only depends on the customer who has a sealer, wants to seal the cans, put in the milk or whatever product they want, and then they want to put the cap end on it, and then if they put the end on it, sometimes it goes bad, and that is you really want to specify that you're not going to have trouble with the sealing of the end of the cap. And so if we put it to 0.00, I don't want it to deviate from 1. I only accept 1. Yeah, so then it says, okay, can access ratio, not good. You see? But you probably want it to 0.04. Because that's what most companies do. If the can is round but still within 0.04, so 0.96 actually, then the can is good to go. This is a quite important setting for most companies, because when the can is not round, then the whole capper will stuck, and that will take a long, that always takes like 10 minutes every time that it stucks to be able to fix the situation, take out the bad can and make sure it starts running again. So that is what you want, that it never stucks on the can sealer. Next issue, the bottom inspection. Yeah, now if we look here, show image, yeah, you see bottom intensity here, you see? Oh, this is the bottom intensity, what we see here. It has two circles. You see those two green circles? Yeah, one circle is depends on the blue circle, and the other one is just depends on the green circle. As you can see, the one that depends on the blue circle is this one. That's the most important one. And the one that depends on the green circle is this one. It says that it has an outer radius of -300, and this is an outer radius of -12. Okay, the 300 means that from the green circle to the small circle, that's 300. And from the blue circle to the green circle, that's 12. But if we look very close, you'll see that, well, the blue circle is something that is found with the learning assistant. So that works together, and that we're going to see right now. And for this to do that correctly, we will have to save next image as sample image. So if you save next image as sample image, now give me a second, there's somebody on the door, I have to look. I'll be back in a second. So let's continue. So this circle, so we have this circle. What we need is a new image. So let's do that. So save next image as sample image. And then we hit on start, and we need to pass one can. Then, if that's possible. Y pen. Good. So now we have this image here. So I stop and I can go to Learning Assistant. Is goed. So this is the new image that it took. Yeah. And then it needs to find the circle. So if you look without image overlays, which we can do, you only see the image of the can, you see? Now it needs to find this dark circle. Yeah, so if it finds this dark circle, then we can look very, very strictly with a circle inside this this dark circle. And so what we're going to do is Learning Assistant. So now we have this image taken from this Save Next Image as Sample Image. We got this new image here. And calculate derivative. Well, this is of course good. Sometimes, let's say, we turn off this threshold. You see nothing. So you need to adjust this. Maybe to put it to 20. Yeah, we got something. You see 15. So this will work. Or sometimes you want to turn on the threshold before segmentation. And then you see you have other numbers, maybe a stronger. If you hit on the detect circle button, you see a house score here, which is in this case 580. It says, I think, yeah. Now if I change this to 64 and I hit the button again, now it's 584. That's better. The higher, the better. Okay, so 583, 584, now lower, 580, so the best number is 64, you see? Good, and then it detects this circle. But you have to, so if I have the wrong borders, it will not detect the circle. So I need to adjust so that it finds like a range where it can find the circle. So I say detect circle, and then it finds it within the range. It finds this circle with a house score of 584, and it uses the blue circle that it found. It uses that to segment the bottom. So you got a perfect bottom. So if the can is not perfectly in the center, it will always find this perfect bottom center. The bottom circle, yeah, and then just you can hit verify settings and you hit OK. So now these new settings are working. So as I show image, and then we go to show analysis images, of course, and then show image. Then it segments the bottom. Image overlays, we show them. It segments the bottom, blue circle. Yeah, and it subtracts 12 pixels from that circle, and that's where it starts looking for errors. Yeah, now this overlaps with this here, you see. So this is a sidewall. The sidewall looks a little bit on the bottom, and it looks also on the sidewall bottom. So errors in this area here will be caught with this region of interest, but it will also be caught with this region of interest, and the green one, and that is where it found this little white dot. So then we can also put a second bottom inspection area. So this one is segmented, you see, that's what it says here, segmented bottom. Now this is unsegmented, so that means that it finds a circle depending on where the can is located. and in this case that is 300 from the location. And we make the adaptive threshold. This is not an adaptive threshold. This is an adaptive threshold, and this is not an adaptive threshold. What's the difference? The adaptive threshold looks at the pixels next to it, so it looks at borders. Let's say that I got a little gray area, and then the gray area is smoothly going to black. Well, that's like that means that the dirt that it found, or the spot that it found, has a soft edge. And that means that if it has a soft edge, that it probably is not real dirt. If it's real dirt, it has a hard edge. So that means that you use adaptive threshold, and if the difference between two adjacent pixels is more than 20, it starts to add up. And if it's not more than 20, it will not add up. And this one in the adaptive threshold, not adaptive threshold, because this one is set to no, it will be if it's higher than, or is lower than 100, that means that it's black. It will also start to add up. But then if it finds all these pixels that are bad because of this threshold, it will add up all these pixels, and if there is found more than 8 pixels of continuous dirt with this edge, then it will say, okay, this is dirt, and it will reject it. Same for here, right? If it's more than 8 pixels with 100, it will reject it. Now let's see what it does. So if I put this number to low, so let's say to 2 or something, yeah, then of course it will find nearly everything, even noise will be seen as dirt. So it will be very sensitive. You see, everything is noise. Every noise that you see, everything is seen as dirt. So the lower, the more sensitive. And the same for this one, right? So if I put this to 2, then okay, if it's put it to 2, then it's not sensitive. And if I put it to 240 or something, so because it's not adaptive, it looks at the absolute values. If I put it to 240, then I suppose everything is lower than 240. So you become completely white. So well, then you have a big pollution. So we leave that at 100. But you see, that's the sensitivity you put it on. And that the 8 pixels is how big is the problem that we found. Okay. So as you can see, you see this little spot here. Now let's try to see what that little spot is. So we see that this is image 523 and the ECI. So let's go there and see if we can find that image. So the images are normally located on the D drive in the ECI images. 523, here it is. And you see that the spot that it found is actually this thing, that feature that really needs to be there. You see, so this is it saw this as not as dirt because it's lower, it's smaller than 8 pixels in this case. What it found. So if you look here, it because it is, this is all soft edges. You see, it's all soft edges. But then suddenly it found that this or this, so this transition from here to here is more than 20, more than the value that we put here. So that's more than the value that we put here, which was 20, and then it will add up. And it will form a pixel of, so if we put this to 1, so that's also we do. So we see what it does. 1 pixel. Let's see what it does. You see, now it found this pollution, and it says that the bottom pollution is 4 times 4. So this pixel here is 4 pixels wide and 4 pixels high. So let's put it back to 8. Okay. Yes. Okay, what is the difference between adaptive and non-adaptive? That is the question you have. Yeah. Okay, I will do that again. So let me see if I can get there with another program. Maybe it works. I don't see it. Let's see. I don't see the... Okay, so what is adaptive? And then I need to see the pixels, but I don't have a program that can see the pixels, the pixel value. But if maybe it's easy. So if we look here, what is adaptive? Yeah. So first, let's say what's non-adaptive. Yeah. So in this case, we see here in bottom inspection that it has an intensity threshold, and enable adaptive is no. So it's an intensity threshold of 100. Yeah. So what does that mean? It means that two adjacent pixels, so this pixel and this pixel here, if the difference in gray value is more than 100, it will say, yes, or actually no, if one of these pixels is less than 100, that's what it means. So if one of these pixels, the gray value is less than 100, that means that it's black or blacker or darker, yeah, then it will be added as an error. Okay? Now, adaptive means, so if we look here at adaptive intensity threshold, it looks at its neighbor. So it looks actually not only at its neighbor, it looks at a couple of neighbors, and it says, okay, I see this pixel here, and then it looks at the pixel next to it. Now, if the difference between these pixels is 20, then it says, okay, or more than 20, then it says, okay, I'm gonna think that this is an error. So it starts to add pixels. Okay, so if it's more than 20, what does that do in reality? In reality, it goes and it sees, for example, this is 10, this is 15, this is 18, and then this is 20. So it only found one pixel here because it gradually goes up, not suddenly. Okay, so that's what it means. Adaptive means that it gradually goes up. It will not see it. And non-adaptive means it just looks at the value and it says, okay, this is less than 100, and then it's not good. That's the difference between adaptive and non-adaptive. Is it a bit more clear now? Huh? No. Yeah, so if the non-adaptive is 100, yeah, it just means that the value, the absolute value of the gray, so the absolute value of this gray, for example, white is 255 and the black is 0. Yeah. So 100, one of these pixels could be 80. Maybe let me go in more better, so no, even further. So this one is, let's say, 80, and this one is 90, and this one is 70. You see, if you have it like that, then that means that they are all lower than 100, so they all add to my error. That is what non-adaptive means, lower than 100. Yeah, but adaptive means that if this is same thing, 80, and this one is 70, and this one is also 80, and this one is 90, that the difference between 90 and 80 is less than 20. So it will not add up. And then the next one is the difference between 80 and 90, sorry, and 70 is also less than 10. So it will also not add up. It will only add up if there is a sudden change. So for example, where could it be? Like here. And from here to here, there is a sudden change, you see? From, let's say, from 70 to 20. So then you have 50 difference, 50 of difference. So that's what the difference is between adaptive and absolute. Yeah, but you must know that when with absolute difference, non-adaptive, it's not a difference. It's just it looks at the value of the pixel. If it's less than a certain number, then it is dirt. Yeah, consider dirt. Yeah, so if you find 8 pixels close together with more than less than 100, it will be dirt. Yeah, but then again, yeah, okay, and then again, if they have a lot of little pixels, a lot of noise, let's say this one is less than 100, and this one is less than 100, and this one is like also dark, less than 100, and this is less than 100. If you see it like that, right? Yeah, then it will also be filtered out. So if you have all this little noise, then this noise filter will filter out, just like with the MXDBC. Has very, very, very small pixels, maybe due to the noise of the camera or to the noise of whatever, maybe a little the noise of the material, reflections, all these kind of things, that will be filtered out. Okay, good. Um, One little thing, this how do you call it? This threshold adaptive can also see lighter things, but this one can only see dark things, right? So the absolute can only see dark spots, but this one can also see some lighter spots. So if there is a white thing laying on the bottom looking against the gray a little darker, then it will also see the lighter spots. Good. That for the bottom inspection. So that appears here, only here. So this is the can search. This is the bottom inspection. Next thing is the side. Sorry, the weld line. Yeah. Well, the warp, just leave it as it is. Don't touch. Yeah. So don't touch. That's like a system parameter. And the weld line, the machine will need to find the weld line, and that is here. You see weld image. You see that this image here. That's the weld image. So if we go to the weld line, it says that the edge response threshold is 60. So if I put this too high, I say show image, it finds no weld image, you see? Because it needs to find that depending on a threshold. Normally if you put it to 70 or 60, you're fine. It will find the weld line. You see? And then it will not watch it. The weld line is something we cannot inspect. So there is a margin around it, which you say I cannot see anything at 30 pixels from my weld line. So it finds the weld line, it looks 15 to the left and 15 to the right, and it says there's nothing I can see there. And that, especially with this weld, which is a very big weld, you see that? It's not like a thin weld, because you have this weld seal. This company seals the welds. So you got all this gray area around it in the end. Good. So that's the how to find a weld. That hardly fails. That if you have the right number, it just works. Sidewall inspection. That's more complicated. Let me generate a new product. Just so let me remove all these. No, not that one, also not. Okay. So I choose the product. Then I add a product. 1, 2, 3. Choose product. Don't forget to remove the product we created here. My product may go, right? Remove. Okay. So I got my product that I made, and let me remove all the sidewall inspections here. No, maybe we just leave one area there. Okay, let's also leave. So in this case we have this. Let's look at area 0. So you see that this area is the inner side of the wall, but then rolled out and transformed into one straight image. Okay, so These numbers you just don't touch. This is what normally they're all set for the same. But if you go to inspection areas, you can add areas to inspect. Yeah? So for example, this area up here is like a very how do you call that? A very nice and equal area. You see? So so if you see that area as this, you can see that there is no dirt or anything on it. For example, the weld, maybe it's difficult to check, or the beads. The beads are difficult to check, but this is one nice area. So if we go to area properties, we see we have two areas, yeah. And for adaptive, it will check, and it will check for edge response. That is two different ways to check the how do you call it? To check the sidewall. And they're both shown here. Yeah, this is the intensity and this is the edge. So the intensity here, edge there, and when we look here in the sidewall inspection, you will, in the area properties, you have an intensity and an edge. See? And adaptive, that is set here. Use adaptive threshold, it's set to no. Okay? So it looks at the intensity threshold. So everything that is below 10 will be considered dirt here. So now let's change this number to 1 and see what happens. Yeah? Sorry, I have to put it higher, I suppose. Give me a second. So nothing, of course. Sidewall inspection. Okay, I have to put it to 200, 220, something. No, 200, 160. I don't know. Let's try. You see, with 260, it sees everything. Everything here is higher than 260. Sorry, lower than 260. So that's when you start trying to see, well, how can I get this better? So put it to the half and see what it does. Okay, still sees things, right? Especially the bead here. So that is a problem still. So this is like a good can, and I see all this dirt. So I go back there, and I say, well, let's try a half. Oh, that looks better, you see? So I see nothing now. And then I say, okay, yeah, I went from 80 to 40, so let's go in the middle of that, 60. Yeah, I went from 80, half 40, but now I go the middle of that, that's 60. It's called iterative. And we go here and see, oh, I see already the weld line. But it's quite good, so I can, probably when something appears here, then I will know that. I will find that. So I could leave it at 40 if I want this to work. Okay? But then I also have the adaptive, I have the edge response threshold. Sorry. The lower, the more sensitive. So if I go to, let's say this is 35, if I go to half, 17, I find this, all these little pixels here, all noise that's there, so that's not working very well. It's seeing too much, and you can see that here. In the edge image. Now intensity doesn't change, edge changes. You see all these pixels here? So that's all dirt. Or maybe it's not dirt, and then if it's not dirt, then it's noise. So I don't want it like this. In that case, I go to, again, back to sidewall inspection. And I say, well, I went from 35 to 17, so let's go to something in between, 28. And probably I don't find anything now. But as we saw during production, and now you produce like 100 cans or so, and you see that it still rejects good cans. And that's because it is too sensitive. And then what you do is, you come to a number that is good enough and not too sensitive. That was 35. But then, and then also you got the pixel sizes, yeah. So this is the threshold of the size. So if I find all these pixels at 17, and I put this to bigger numbers, for me it doesn't work. For me, 10, 10, 100. And I say show image. It still finds all this dirt, you see, or all this noise, but because all the little noises are smaller than a certain number, I still have this accepted. Yeah, so that's the threshold of the size of the pixel that it finds. Most of the time we want it small, and we want this to be small, so we put it to because we wanted to find small issues, but then we have to then we will, this was I think also 4. Doesn't matter, it is not our production recipe. But then we have to change this to a certain number so that it's not going to see all these little things. But when it sees something, if it's bigger than this, it will throw it out. Okay. And that is the area all the way until this bead area. So we add another area. You don't see it, but it added it here. See, on the same place. And you can make as many areas as you wish, depending on how you want to check this area. So you say, I want to check only this beading area. You can do that, and you can add your properties here. Now this is then probably, you see, this went automatically to 60. We had it at 35, but maybe we want it to 40. And this we want to 40, or I don't know. It depends on what you find, of course. And then we have to look, and we'll see that second area is going to be looked at differently. Give me a second. Site 1 inspection. So this area was set at 35, absolutely. And then the first area was set at, this area. If we put that area more sensitive to 15, then we get this second area as problematic. You see, now we got only our second area problematic, and we find only dirt in the second area. See, so you can set every area as sensitive as you wish. And that's important, as sensitive as you can go, actually. Also, you as sensitive as you can go, while it's still not rejecting too much good products, or actually no good products. That you don't want that. So this is going to probably go to 40, and then we add another area. It already did that. It puts it over the other, and you make all these areas work, but they all need to overlap so that you don't miss a little part. So you can overlap it a little bit, you see? They're overlapped and they're overlapped and all that. But what we found out while producing is that it rejects on this here. This is a reflection of this here, and these are a reflection of these. See that? They don't produce problems, those, but this produces a problem. So what I did, you can add another extra area and make it detect this this little thing here. Sorry. Oh, it needs to go from completely left to completely right. Because it scans the whole area for this thing here. And then we need to add to area properties. And we need to say that this thing can be reflected over there. So we need to add a reflection source, yes. So now it's a reflection source. So it's not going to reject on this area. It's only going to find this reflection thing. And then we put this edge trace, I think I was put to 20 or something. So if I say show image, it found all these, it found too much. You see it in blue. So not image days, okay. You see it finds all these. I think this is not necessary to find, so we find this reflection image too sharp. So we go back to that reflection area, which is area 4. And we say, okay, nah, not so sharp, maybe 25. Okay, you see? Now it nearly only finds this dot. Maybe I don't want to find this dot here. So I will also, I make it a little bit bigger. Still, so that it's less sensitive. Oh, wait a sec, cancel, it was area 4. That's a very common error, that you change the wrong area. Put it to 30. Let me see what it sees. It probably only finds, okay, now it only finds my dot here. This dot that reflects exactly there. So if I want to, and now I want to remove, so I don't want to reject here, because for some reason it starts rejecting there. So let's put an ROI there. So add area, and that's exactly here, right? So that area we haven't covered yet. So let's say that let me see. Yeah. So let's see if it sees. Okay. So let's see if it rejects on that here. You see, it found this reflection. The reflection here, it found it, and it says, "Uh-oh, it needs to be rejected because the dirt that I found is too big." So in order to avoid that, I'm going to say that this is a reflection by telling this ROI number 5 that it removes reflections. You see? Remove reflections. So only in this area. So what does it mean? It will only remove, if it finds something here, it will remove it there. So it will not look there. And now it's accepted, see? So I found this, but then I say, okay, this is a reflection of this, so I will not look here. Okay, is that clear? It's quite complex, but it's quite essential also. Okay. That is a sidewall inspection. I think I covered everything in the sidewall inspection now. Yeah. So that means that we go to the flange now. Enable flange inspection. What you see here, it's turned on. You can turn it off if you don't want to inspect the flange. What is the flange? This is the flange here. So this area here. So we will have to indicate that this is the flange area first. So when we go to flange, we got this flange ROI button where you have to select the flange. And this flange, it will look from top to bottom, and it will find all pixels on the flange. That's the reason why you need all these, the area black around the can. You want a black area. You don't want to have gray shadowy things here, because it will not work nicely. So make this black, and then you can look at this edge from the top, and that's what it says here. It says intensity threshold top. Okay, 80. So now we're going to look in view mode, show analysis images. We're going to look at the analysis images to see what it does. It's quite small on the screen, but you can see that in the flange image, it is the weld image, the edge image, the intensity image, and the bottom. We have seen them all. Now we are here at flange, and you see this blue line. So it looks from top to bottom and it finds a threshold which we had put here of 80, and it finds this edge, and then the derivative is it looks at, let's say, how it changes in the y-axis is plotted here. Now if your machine is well adjusted and you have a nice derivative, so a nice line here, you will find that the derivative is small. If you got an error, then the derivative will be big. And then, of course, in this case, what we see is it says only consider top, because we are only going to consider top. Yeah, that means that we're not going to look at the bottom. You can also turn that on for sure. So I put to no. We got an intensity threshold on the bottom, and it will find two lines. You see, but it has shown to be not so, how do you call that? Not so stable. So we normally turn that off. That's still in development. So we put that to yes. Okay. So we only see the top. Good. Now maybe we should make a dent in the flange and run one can so that we can see what an error does. So make us a small dent. And pass the can through the system. Yeah, thank you. Well, I don't see the dent. There's no dent in the flange. Or at least not visible. Maybe there is, but it's too small. You see here something? No, that could be the weld line. Okay, now we have a dent here. Good. So we're going to look at what it does. You see that the dent gives a derivative here, and the derivative is shown here. You see? And then if the derivative is more than the set number of a half, which is the threshold. Yeah, in this case it's a half. And it has a minimum width, so if it is 7 pixels, above the threshold, so this is maybe less than 7 pixels above the threshold, but this is more than 7 pixels above the threshold, and that means that it is a reject. Okay, so that's what it means basically. Okay, so if it is 7 pixels above the threshold, then it is considered an error. Now weld width, that's the last thing here on this sidewall, on this flange roy. Because this is the weld, you see the weld is always a problem, it always has been a problem. It gives this error here. Where the weld is, because it finds it dark, so it will find a thing here, and it will say, okay, I got this weld area here, and then left and right of this weld I will not look, and in this case it's 10 pixels. So it will not look 10 pixels left or right from the weld, because it cannot. Okay. Okay, so that is it about the ECI. So that's what the ECI does. Don't look at the button. Those settings are still like in development, or somebody asked for this, and it's not something that you want to use. So that was the ECI. Is there anything else that I want to show? No, that's about it. So let me stop the